Okay, let's have a look at challenge number 47. So this thing, we're going to do something called a VIN, so vehicle identification number. What do we have? Let's just move this in a bit. Is some kind of long string of digits to identify the vehicles. They give a link for the Wikipedia page, so we can go down and have a look. So it's uncoded means probably absolutely nothing. There's some kind of logic we need to apply. So such that in end, for each of those IDs, you have some kind of digits you can check against to see if it's true or false. Then there's some additional margin or bound to decide it's a correct number or not. First, let's have a look at the Wikipedia page. It's probably make more sense. Turns out excuse me. Turns out the process. The first thing you're gonna apply is transliterating the number. So basically, you're gonna just encode your input characters, letters into the number corresponding. Once the number is done, you're gonna depend on the position because you have a long string. You're gonna apply a weight for each of the thing. Among those, the particular thing is number 9 itself is your checking digits. They use a 0 to weight, but we can pass out a number to replace. Once that's done, that's mainly the workflow gonna handle. So we're gonna have some kind of input number, input a list, then we're gonna translate to numbers only, apply the weight for each number, then apply the product. With the product, you calculate the group sum. Once the sum, you do a modular calculation and use that number to check against. So this one took me longer to read the Wikipedia page rather than actually doing the challenge itself. But that's it. Let's give this thing a try. So the first thing we know, the next character is the check digit. So let's actually pass that out first. If you're looking for specific digits, then that's you can use as a substring. So we know we're looking for the next character. So the next character is ring. We calculate from the ace, the length is 1. Because actually counting from 0. It's a character, so character is fine. Let's first. So what we have x16, the other one. What? Let's sort the thing so it's easier to see. Da-da-da. What's their sorting algorithm? They are not using sorting. I think they sorted different. They sorted with a number in front of it. Use not use dictionary order. Yeah, that's a separate note on the sorting. If you use dictionary, they basically treat the characters alphabetically. They try to sort. If you don't sort it, I think that goes to the number first, then go to the letters. So yeah, we can see we have a 194x1 xi6, 194xi6. So that's a digit we use to check against everything else. That's done. For the rest stuff, that's because we're gonna handle each characters. We're gonna tokenize our things. The first thing is record ID. We want to make sure they are in the correct batching orders. Once the record ID is done, we can start to tokenize our characters. We have a regex. To tokenize, we can use just a dot any character. We're going to tokenize two rows. Let's look. So for each batch, group by the ID. That's what the first one's not. So for example, the second batch, you have the digit 1, 2, 3, 4, 5. So every time you see a character, it go to a new row, character, new row, etc. So we do expect 17. That's good. That's 17. The next should probably ends up 34, 33, 34. Yeah. So at least we know we're patching in the correct sense. Because we tokenize, it's always good to label the tokenizer stuff as well. So I want to use the tiles tool, group by. We want probably unique values. What do you want? No, you don't have unique, you need a smart tile. Equal records is probably fine. So we have 6 records, we have 6 tiles. Do you want to group by record ID? Still not in one, right? What was 17? Mm-hmm. Hopefully that's for number 4. He ends up 788. Number 4 ends up 788. Yeah, that's fun. Because tiles can shift things around. It's always important because every time you tokenize into your rows, the order matters. So you try to keep your record D as early as possible to keep track of everything else. So for us, all I need is the tile number 17. I think smart how probably do the job as well, but depends on the setup. For this particular case, it works, then I'll keep as it is. So record ID gave you a batch number, tile number gave you the letter number. Then we can do our conversions. Now with that, let me just copy my previous workflow. I did some pre-transformation to produce the lookup table from the Wikipedia page. To save time for the video, I'm not gonna do that again. What you have a list of your letters. Now from the page, we can see some letter is omitted, probably because of avoid confusion with the numbers. So rather than 26, we have 23 letters. Second is weight. Weight depends on the position of the number. With those things, let's do apply join first. So transliteration. Okay. Transliteration depends on the characters. So we're gonna no, it's not join. It's find and replace. Because sometimes you have numbers, we don't want to replace the number, we just want to replace the letters. So for us, it's the main column. We're looking for any pattern here because we're single length, so it doesn't matter too much. What you're looking for, we're looking for the transliteration key, so the letter. If you found that, you want to replace with the transliteration value. Replace multi-font, default font because we now have multiple match because each cell is a single character. That should replace, so it convert all the letters into numbers. Any numbers, you don't have any replace, so it will be as it is. So let's see. So you have 1M8G should be replaced 1487. So 4 and 7 should be the letters, should be MG. M replaced to 4, G should be replaced by 7. So it's doing the correct replacement. Then we're going to do it as a join. Depends on their position, so tile number. We're going to apply a weight onto the cell. So we're going to join the left hand side of the tile number, the right hand side should be position code. We don't care position, weight is fine, record ID, tile sequence, we can probably drop that as well. I think, yeah, tile sequence is 1 everywhere. So you have a record ID, and that's why the importance of record ID, because the join will shift things around. Character still there, order still there, weight is there, that's fine. Then we can calculate our product. Now what do you see product? Is everything in numbers? Vin is still string. We need to change the string. So we were interested. We're looking for two number. Hmm. Let's just change the date type here. Because the should be number, you casting to integers should be fine. Shouldn't cause any troubles. If you get that error, that's actually a good indication there's something wrong with the code. In your probably in the initial find a replace, you need to go back and check your stuff. So the Vin should become an integer now times the weight. We're gonna get still integer. That's 64. Da, 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 da. We're getting now. So that's actually good. It's not. We'll look in the error message. IQQ. I think IQ is no. Yeah, I is no replacement. OPQQ is no replacement. So the child is not allowed as a valid being for the child. They have been filled with the name. Yeah. Mm-hmm. So we have already some characters that's not allowed to happen. So this way, I would probably filter here. So those are the things you need to do data quality check and please say, okay, there are some specific records we are not allowed. Mhm. Let me have a look. How do they handle I and Q? Yes, let's go back this one. So I and Q is not allowed. And did it be filtered? Because of that, it's some kind of dummy string we created here. So that's an I and Q. In real life, you probably have a filter to get those ID go out and to be processed to say, okay, there's something I'm wrong without even going through the rest process. For us, this particular case, it's literally keep in the data set, see how this thing is getting weight captured because it's invalid expression. It depends on how you handle it. If it's say you handle zero, you probably have them missing digits. The check digits should match. Let's see. They produce null value. We try to cast this integer. You have now. You shouldn't pass anything. Okay, then we're looking for one group by for each record ID. The product, we want to do the summation of it. These are digits. Because we do summation, if you have null values, they probably just treat it null. So rather adds up 17 values, adds up 16 values. So you want to do a formula. You want to check mod. Let's see. So blah blah blah. You're looking for mod 11. Mhm. So we want to mod our sum or product. Mod 11. So cast is integers fun. You get the digits. The digits. Okay. Then the remainder is the check digits. So if it's a 10, replaced by x. Else if the check digit, else if we keep the digits. Completed. Let's say that digits. So we have x. So we're gonna keep as a string. If our check equal to 10 is the number at the moment, then you replace that with an x. Else to string. We're gonna keep the check number. That. That's done. Let's see. So we have our different record ID. You have your corresponding conversion. On top, we have the passed out digits. The passed out digits, It's good. It's a string, so we can compare things directly. Let's continue to our join. So we're gonna join on the record ID. Let's get a bit closer. Let me just lamp my stuff a bit. So we're gonna join on record ID. Hmm. Let me just get rid of this thing first. Just connect the branch. So we're gonna have a record ID on both case. Oops. So we have a record ID, record ID. We don't mind the record ID. As this cycle, we care about each V number, the corresponding record ID. You pass out check digits, then we have a calculated digit. That's the thing we want to compare with. So XX, so the IJK, because if IQ, that's definitely wrong. The pure number one, that's wrong. Then the one FAL is mismatch. So number is wrong, one FA match, the pure number is incorrect, so invalid being number. And that is quite interesting workflow to set up the process logic. The longest part is literally reading the Wikipedia page and probably producing, you do some additional work to produce the two lookup table. But once it's done the first time, then the rest to apply was much easier. Okay, thanks for watching.